Alright folks, welcome back. I'm here to do another video on basically calculating the frequency given the wavelength. Okay, so here they say we have a laser commonly used in the treatment of vascular treatment of vascular skin lesions. Has a wavelength of 532 nanometers. What is the frequency? Alright, before we can get started, we need to know the wavelength and frequency equation involving the speed of light. Did you see me? I just happened right in front of you. I just appeared and disappeared. The speed of light. I am super fast. Did you even see it? There I am again. Oh. Alright, anyway guys, so I know it's just a joke. So, anyway, I'm sorry to go off on a tangent. I don't think I've drank too much Kool-Aid. Alright, but anyway, so go ahead and try to work this problem out. So, basic things that you need to know. You need to know the following. C equals V times lambda. Now, the V itself is the frequency, and the lambda there is the wavelength. And that's what we're going to have to move around and deal with to get the frequency by itself. So let's see what we can do. Better yet, what else do we need to know? We need to know C, the speed of light. Alright, the speed of light is like 2.998 something yada yada yada. Well, we usually just use the following for the speed of light. We usually just use 3.00 times 10 to the 8th meters per second. Okay, that's the constant for the speed of light that we use. If you need to be more exact than that, then I guess go look it up and write that down. But for most part, 3.00 times 10 to the 8th meters per second is going to be good enough and accurate enough, because the other one, usually if you had another piece of equipment that measures all the way down to like the 10,000ths, then I guess it would make a difference. But most instruments that we use in high school will never measure down to that, or even in college. So 3.00 times 10 to the 8th meters per second will work just fine. Alright, so let's go ahead and try to solve this for frequency. Alright, remember, now I said that this one was wavelength, okay? That's wavelength. Okay? So we need this. We need to solve for this. We need to get this by itself. Okay, so let's do some algebra. Now, this is V times lambda. Now, what undoes multiplication? Well, it's opposite. What's its opposite? Well, you probably already said it twice. Division. We're going to take this wavelength and put it underneath C. So that gives us V equals C divided by what? Our wavelength. Okay. Now, the speed of light is 3.00 times 10 to the 8th meters per second divided by our wavelength. Now, our wavelength is 532 nanometers. Whoa, 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 whoa. That is not meters. We need it to be in meters. Now, here's the reason why. Velocity in physics is measured in units of meters per second. So we need this to be just meters. Now, I don't know about you, but I'm kind of lazy. What I will do is, since it's not the final answer, and I'm just moving things around to get it set up so I can work it, I'm going to make sure that I get this in units of just meters and not have this prefix nano hanging around. So this is what I'm going to do. I'm going to do it the lazy man's way. So watch. 3.00 times 10 to the 8th meters per second. Now, if you remember from class, you will remember 532. Okay, I know you're thinking, I've known that since elementary school. Okay, but that's not what I'm talking about. This nano. We need to take care of this nano. Okay, that is a prefix. It means it's times 10 to some power. So I'm going to go ahead and write down times 10 to some power. Now, what power am I going to write here? Now, it is nano, and it's a prefix. So it's times 10 to some negative number. Now, if you don't know what that negative number is, let's look. First of all, you had kangaroos hop DA under drinking chocolate milk. And you're supposed to have memorized that there's two jumps here, XX, and then you have micro, okay? And you have XX, and then you have nano. Well, if you look, that is from U, which is units, meaning no prefixed units. That is 1, 2, 3, 4, 5, 6, 7, 8, 9 moves. Okay, that's 9 swings. So that's to the negative 9. That's what the prefix nano means. It means to times 10 to the negative 9. Times 10 to the negative 9 what? Meters. So basically what we just did was we changed out this prefix nano with the times 10 power of negative 9. Now, if you notice, I was extremely lazy and did not change the 532. I kept it that way. Now, I can do that just because it's not going to be in my final answer. Okay, that's the only reason I'm doing that. Okay, so I'm not being graded on the work that I show, and the work that I've shown is technically still correct by writing it this way. So that's the way that I have always done it as a student in college and as a teacher and professor. So just remember to make sure that you mark that, and that's the prefix of nano is negative power of negative 10 to the negative 9. Just put meters back on it. But anyway, we're done with this other than punching it into the calculator. So let's do that real quick. Let's pull up a calculator that I seem to not have pulled up anymore. Okay. Calculator. There we go. Alright. I need to make sure that this thing stays on top because I'm going to have to write on it. Let me make sure that it's in the right mode. Yes, scientific. Good. Alright. So let's go ahead and punch this in. I've got 3 point. Now, if you really want to, you can make sure to use parentheses on that. If you're paranoid, 3.00. I'm not paranoid. I swear. Times 10 to the 8th. Close your parentheses. So that way you've got I guess extra insurance, so to speak. Divided by parentheses 532. Times 10 to the negative 9. And then I'm going to close my parentheses. Okay, so I'm going to hit equals. Now, this is my answer. I get 5.639097744 times 10 to the 14th. And that's correct, but as far as sig figs, I need 3 sig figs because the original problem had 532 is the only number given, so I'll need to use 3 sig figs. So let's go ahead and do that. Equals 3 sig figs. So the 5's significant point, the 6 is significant. Now I need one more number. Okay, that one more number is going to be this 3, but to the right of that 3 is a 9, so it's going to change it to a 4. Now be careful, don't just stop here. Go ahead and always check the ending of the problem. It's times 10 to the 14th. Okay. And as far as our units go, we need to look back here and see what they were. Notice that meters would cancel out. Let's like make it slash type. Slash. Meters is gone. And the only thing left is this fraction bar S. So really the units of that then is just 1 over S. Now, that means there's this many meters going on for every 1 second. So, meaning, not meters, there's that many cycles going on in a second for this. So, it's hertz. So, what we need to do is change this to hertz. So, this is 5. Now, I always leave this one up here. Just in case if I ever have to use it again at another problem, like in a substitution method. So make sure that you keep it, out and about. So that's 5.64 times 10 to the 14th, and hertz is capital H with a little z. So there's hertz. Now we're pretty much done. But technically either one is correct. But I've always been taught to put hertz on mine, so make sure that you put hertz on yours. But like I said, don't just write one. I would write both. That way you have both in case they ask you another question below it, like, calculate the amount of energy in the following, and then you need to use, this. So, and like 1 mole of that light or something. So, but anyway, just make sure you keep track of this, write both of them down, and you should be good to go. Alright, guys. I hope this one was helpful, and I hope you appreciated the little bitty shortcut that I showed you right here. Alright, guys. Y'all have a good one.